Welcome in the video series of Mathematics class 10th. Dear students, in this video we are going to learn the second chapter of Math Second, that is Pythagoras theorem. So let's start with the Pythagorean triplet. Dear students, to understand the concept of Pythagorean triplet, let's take an example. So here we have the three numbers. We have to identify that whether it is a Pythagorean triplet or not. Okay. So let's find out the square of all these three given numbers. That is 11 square is 121. Square of 60 is 3600 and square of 61 is 3721. So here, if the square of largest number is equal to the sum of the square of remaining two numbers, then we can say the given number is the Pythagorean triplet. Okay. Now here the sum of the square of remaining two numbers, that is 121 plus 3600. Their sum is 3720, which is equal to the square of the largest number. Okay, that's why here we can say that the 11, 60 and 61 is the Pythagorean triplet. So in this way we can find out that whether the given numbers are or is a Pythagorean triplet or not. So here these numbers we can write in any order in the Pythagorean triplet. Dear students, last year we have studied the properties of right angle triangle with the angles 30, 60, 90 degree and 45, 45, 90 degree. So let's first see the property of 30 degree, 60 degree and 90 degree triangle. If acute angles of a right angle triangle are 30 degree and 60 degree, then the side opposite to 30 degree angle is half of the hypotenuse and the side opposite to 60 degree angle is √3 by 2 times the hypotenuse. Dear students, here we have the triangle ABC, in which angle A is of 30 degree, angle B is of 90 degree and angle C is of 60 degree. Okay. Now here, according to the property of this 30, 60, 90 degree triangle, here the side opposite to 30 degree. This is your 30 degree angle. So its opposite side is BC. So this BC is half of the hypotenuse, that is AC. So side opposite to 30 degree, that is BC, it is half of the hypotenuse. BC is equal to 1/2 into hypotenuse. Similarly, the side opposite to 60 degree. Here the side opposite to 60 degree is AB, which is √3 by 2 times of the hypotenuse. That's why this AB is equal to side opposite to 60 degree. That is AB is equal to √3 by 2 times of hypotenuse. That is AC. So this is the property of 30, 60, 90 degree triangle. So in this case, you may given with the any one sides from these three sides. You will be given with any one sides and you will ask to find out the remaining two sides. So in that case, this property will help us to solve the question. Now let's see the property of 45, 45, 90 degree triangle. If the acute angles of a right angle triangle are 45 degree and 45 degree, then each of the perpendicular sides is 1/√2 times the hypotenuse. So dear students, here we have the triangle PQR in which the measure of angles are 45 degree, 45 degree and 90 degree. Okay. So here the length of each perpendicular side, that is PQ and QR, these are the perpendicular side. So here this PQ is 1/√2 times of hypotenuse, that is PR. Okay, so PQ is equal to 1/√2 into PR. Similarly, this side QR, that is also 1/√2 times of the PR, that is hypotenuse. Okay, so in this way, in a triangle with the measures of angles 45, 45 and 90 degree, then the length of this perpendicular side is 1/√2 times of the hypotenuse. Now let's see the similarity and right angle triangle. In a right angle triangle, if the altitude is drawn to the hypotenuse, then the two triangles formed are similar to the original triangle and to each other. students, to prove the Pythagoras theorem, we should know the theorem of this similarity and right angle triangle, or we can say property of similarity in the right angle triangle. So let's first try to understand what is there in this theorem. So according to the statement that in the right angle triangle, if the altitude is drawn on the hypotenuse, then here two triangles are formed. So here we have to show that these two triangles, these two small triangles, these are similar to each other as well as these are similar to the original triangle, that is triangle ABC. Okay, so let's prove this. So for this, figure will be like this, and now let's write out the given. So in the triangle ABC, angle ABC, this angle is of 90 degree. Then here this segment BD is perpendicular to the hypotenuse, that is segment AC, in such a way that these points A, D, C, these are collinear. Okay, now what we have to prove? That triangle ADB, this smaller triangle, is similar to the original triangle, that is triangle ABC. Then triangle BDC, this downside small triangle is similar to this bigger triangle ABC, and these both the small triangles are similar to each other. So like this, these three pairs of triangles we have to show them as a similar. These students, we are knowing that to show any two triangles as a similar, so we have to show at least two pairs of congruent angles. Okay, so here let's take this first two triangles, that is triangle ADB and triangle ABC. So in the triangle ADB and in the triangle ABC, this small one and this big one. So you can see here this angle A. This angle A of this smaller triangle, that is triangle BAD, this, and for bigger triangle BAC, same angle is there. Okay, so here we can say that this angle A is congruent to angle A, that is angle DAB is congruent to angle DAC. Okay, common angle. Similarly again another pair. Now for this smaller triangle ADB, angle D is of 90 degree, and for this bigger triangle ABC, angle B is of 90 degree. So in this way we got the second pair. So here angle ADB and angle this D and this angle B, these are congruent, each of 90 degree. Okay, therefore by AA test, both the triangles are similar, that is triangle ADB similar triangle ABC. Okay, so let's give it as a first one. Now let's take these two triangles. Okay, that is this small one downside triangle, that is triangle BDC, and original one ABC. Okay, now here also for this smaller triangle BDC, this angle C. Okay, and for the bigger triangle ABC, same angle is there. Okay, so in this way we got the one pair of angle, that is angle BCD congruent to angle ACD. Okay, that is common angle. Okay, now second pair, that is for the smaller triangle BDC, this angle B, that is angle BDC. This angle B is of 90 degree, and for bigger triangle ABC, this angle B is of 90 degree. Okay, so in this way we got the second pair, that is angle BDC congruent to angle ABC, each of 90 degree. So here also by A test, these two triangles are similar, that is triangle BDC similar to triangle ABC. Let's give it as a second. Now dear students, you can see here in the first and second, what is the RHS? Triangle ABC, here also triangle ABC. Okay, so from this first and second, as the RHS are similar, they are equal. Okay, RHS are equal. That's why we can say here this LHS, that is triangle ADB similar to triangle BDC. Okay, so from first and second we got this triangle ADB similar triangle BDC. Okay, let's do it as a third. Okay, so in this way, here first triangle is similar to the second is similar to the third. That's why here all these three triangles are similar to each other. This is the property of transitivity. Okay, so in this way, here all these three triangles are similar to each other, and we have proved that in a right angle triangle, if the altitude is drawn on the hypotenuse, then these two triangles are similar to each other as well as to the original triangle. Now dear students, let's see the theorem of geometric mean. In a right angle triangle, the perpendicular segment to the hypotenuse from the opposite vertex is the geometric mean of the segments into which the hypotenuse is divided. Dear students, in this theorem, according to the statement, we have to prove that in a right angle triangle, the perpendicular drawn on the hypotenuse from the opposite vertex is the geometric mean of the segment into which the hypotenuse is divided. It means that we have to show this QS is the geometric mean of the segment RS and SP. Okay, that is QS square is equal to PS into SR. This we have to show this. Okay, so here we will consider this two triangles. That is triangle here in the right angle triangle PQR. In this right angle triangle PQR, this QS is perpendicular to the hypotenuse PR. Okay. Now we got the two triangles. That is triangle QRS and triangle QST. Okay. So here these both the triangles are similar. That is triangle QSR similar triangle PSQ. Why these are similar? So just now we have studied that is similarity of right angle triangle. Okay. So according to that, these two triangles are similar. Okay. Now let's write down the ratio of their corresponding sides. So here QS upon PS is equal to SR upon SQ is equal to QR upon PQ. Okay. Now here what we have to prove, according to that we don't need this QR upon PQ. So we take this only these two ratios. Okay. So that is QS upon PS is equal to SR upon SQ. Now let's take the cross multiplication. Okay. So QS into SQ, that is QS into QS, that is QS square is equal to here PS into SR. Okay. So in this way, what we have to show that we have proved. It means that here segment QS, this segment QS is the geometric mean of these two segments, that is RS and SP. So dear students, for 2 marks you may get a question in which from these three segments any two segments will be given, length of any two segments will be given, and we have to find out the third one. So to get that third one, we can use this theorem of geometric mean. I hope the theorem is clear to you. So dear students, in this video we learn the property of 30, 60, 90 degree triangle, then 45, 45, 90 degree triangle, then what is meant by a Pythagorean triplet, also the similarity of right angle triangle and this geometric mean we have studied. I hope all these theorems, all these properties are clear to you.